Okay, so this is the days 1 through 4 review. This is everything that we've learned this week for this chapter, and I think this is a great overview of what's to come next week on your test. So let's go ahead and get started. When you are done, you can check your work with the sub and go ahead and get the review for you to try. So this very first one, it says multiply the factors of the function below. So that's in standard form. So we need to go ahead and distribute here. So what does it mean to distribute? That just means to multiply. So I'm going to go ahead and do 2x squared times x. Well, when you multiply x squared and x, you get x cubed because 2 plus 1 gets you 3. So I'm going to get 2x cubed and then 2x squared times -2 is going to get me a -4x squared. Now that becomes a group, and we want to bring down the x plus 3, and we're doing just a lot of multiplication here. So now I'm going to take each one of these terms. I'm going to take this 2x cubed first, and we're going to multiply it to both of these. So 2x cubed times x would get me 2x to the fourth. 2x cubed times 3 is just going to get me 6x cubed. Now remember, you're really just multiplying those outside pieces. 3 times 2 gets you 6. That's why we have 6x to the third power. Okay, so here in purple, we have -4x squared times x. That's going to get me -4x to the third power, or -4x cubed. And then I have -4x squared times a positive 3. Well, -4 times positive 3 gets me -12. And then the x squared kind of just tails along with it. Well, last step here is to combine like terms. So when you combine like terms, you have 6x cubed minus 4x cubed. So it's like you're doing 6 minus 4. So 6 minus 4 gets me 2. Bring down the x cubed. The powers don't change. You're still going to keep it x cubed. If you had 6 of something and you took 4 away from it, you still have the something. It doesn't change the variable. Bring down the -12x squared. Bring down the 2x to the fourth. And we are all done. All right. Let's go ahead on to the next one. Now this next piece, the biggest misconception is just distributing that 2 in. But this guy right here really means x plus 2 times x plus 2. Bring down the -2x. So let's go ahead and start our distribution, which really just means to multiply. So -2x times a positive x just gets me -2x squared, because remember, you're just adding the exponents. If I have one x and another x, I now made two x's. I have -2x times a positive 2 gets me a -4x. That now becomes a group, because that x plus 2 is just going to be dropped down right here. Do it again, just like we did in the first example. Every term in the first group needs to be multiplied to the second group. So in blue here, I'm going to do -2x squared times x is going to get me a -2x to the third power. Remember, you're just adding exponents. -2x squared times 2 gets me -4x squared. All right, move on. This guy is done. We're done with him. So let's go ahead and move on to the next one in green. I have -4x times x gets me -4x squared, because x times x is x squared. -4x times a positive 2 gets me a -8x. And we're almost done. We have to combine like terms. Be careful, they don't just cancel out. -4 minus 4 is going to get you a -8x squared. Again, if you owe someone $4 and you borrowed 4 more, you now owe them 8. Bring down a -8x. Bring down the -2x cubed, and you are all done. That is in standard form. Okay, let's move on to the next part. This is the one where a lot of people struggle with because the calculator was kind of difficult to work with. So I'm going to go ahead and bring mine up. Okay, so the first thing you want to do is press this Y equals button with your graphing calculator. Clear it out if you need to, so press the clear button if you need to. I will make this bigger so you can see what buttons I'm clicking. And we're just going to type in this guy that we have right here. So I have X. In order to get to the power of 3, you have to use this little arrow button right here in red and press 3. You want to, because you can see the cursor blinking, you want to press the right button to get out of the exponent. Minus x squared minus 12x. And then if you notice here in gray here, we have this new window. We need to make sure that's what our window is. So press window. It looks like negative 10 and 10 are there for our x's, but here our y's is negative 50 to 50. So I have to press the down button. And I want to put negative 50. And then I want to put 50. Because now we'll get a better graph when we do this. Press graph. Perfect. Okay, so remember there were 4 things that we needed when we graphed something. We needed the x-intercepts, we needed the y-intercept, and we need the max, and we need the min. Okay, so let's figure out what our x-intercepts here. We have one at negative 3 right here. This negative 3, 0. Negative 3, 0. We also have another one at 0, 0. And we have one more right here that's 1, 2, 3, 4. So it's 4, 0. Let's figure out our y-intercept. So we can see our y-intercepts right here. We don't know exactly. It looks like it's at 0, 0, but we don't know that for sure. So in order to see your table, you press the blue button second and then graph, and that gets you your table. And if you look down here, that is true. At 0, 0 is where our y-intercept is going to be. We need 2 more things. We need our max and our min. So to get our max, we have to press second trace, and let's go ahead and find our max, which is option 4. You can scroll down and hit 4, or you can go ahead and just press 4. Now left bound, that means here's my cursor. I want to move that cursor to the left side of where I think the max is. So I'm going to press the left button until I get around there. So left, left, left of where I think the max is. So here's the max. I want to go left of it. My cursor's blinking and it's on the left side. Press enter. Now it says right bound. So I want to go the right of where I think it is. So go right, right, right. And now it's the blinking cursor is on the right side. Press enter. And it says, do you want me to still guess? Yes, I do. Press enter one more time. And it looks like our maximum is at the x value of negative 1 point, let's round it to 7. And our y value, remember this is always your y value, of 12, let's say 0.6, because we rounded. Remember our maximum here is technically at negative 1.7 comma 12.6, but when we write it in the statement, it has a relative max at the value of 12.6 when x is negative 1.7. Let's do it again to find our min. Second trace, press min. And here's our min right here. We want to go to the left of it. So we are on the left side, but let's go closer so that we get it to be a little bit more accurate. So now my cursor is blinking. It's pretty close to the min. You can go closer if you want. Press enter. Go the right side of where that min is. Go right, 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 right. Press enter. Enter one more time. And it tells me that my min is at 2 point maybe 4. You can just leave it at 3 if you want. Negative 20.7. And when we write out our statement, it's always the y value first, so negative 20.7 at x equals 2.4. And now we have all the pieces that we need in order to make this graph happen for us. So we have negative 3, 0 is going to be our x-intercept. So I'm going to put that in there, negative 3, 0, 0, 0. And we have 4, 0, 1, 2, 3, 4. Our relative max is going to be at 12.6. So maybe we want to go up by like 2s or 3s so that we can do this. Let's go up. Let's go by 5s. I feel like 5s are pretty easy. So 5, 10, 15, 20, 25, 30, etc. Same thing, negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, etc. So let's go ahead and graph that. So I have 12.6 when x is negative 1.7. So here's negative 1.7. Go up 12.6, which is like maybe right here. And then we have 2.4. So 2.4 down 20.7. So 25, 10, 15, 20.7 is maybe around there. And from left to right, connect the dots. So I'm going to connect the dots. Here's our max. Here's our min. And it goes up. And then let's just finish that graph off. Now, if you looked at your graphing calculator, that looks very similar. So let's fill in the remaining of this. The domain and range of all odd degree. We learned about odd degree yesterday. Odd is opposite. And that means it's going to go forever left. It's going to go forever right. It's going to go forever down. It's going to go forever up. So all real numbers is our answer for the domain and the range. That just means that all x values possible would exist on this graph, and same thing for the y's. Your zeros are just like the x values of your x-intercept, so negative 3, 0, 4. Interval of increase and decrease is always the topic people get stuck on, and what I recommended on day 2 was to make sure that you draw that dotted line kind of like as a barrier or a wall, and it's always going to be at those x values. So this one was at negative 1.7 and the other one was at 2.4, and that's going to help us out here. I like to label my graph here in blue, negative infinity to positive, when I'm working with interval of increase and decrease. So from negative infinity all the way up to my first little barrier here of negative 1.7, you can see that the graph is going to be increasing. So from left to right, this guy is going to increase. So I'm going to have negative infinity to negative 1.7. Where you stop is where you start. So you can see here in pink at negative 1.7 to 2.4 that this is going to start to decrease. So this guy right here is decreasing. So I have negative 1.7 to 2.4. Where I stop is where now I start. So I'm going to go from 2.4 all the way to positive infinity, and that's going to be where it increases. So 2.4 to infinity. Again, if you look from left to right, this guy is going to increase right here. So increase. And then this guy was decreasing. That is a hard topic to understand because you're describing where on the graph you're increasing. So for example, from 2.4 years and on, my company was making money. Okay, so yeah, I started off in the negatives down here, but I'm still making some kind of money. So I'm increasing. So years 2.4 and on, I would be making more money, which is what your y values are. Just a kind of a little bit of a scenario for you. All right, this next part. Write the equation given the parent function and transformations. So something to make sure that you write is the actual transformations formula. So g of x is equal to plus or minus a, x minus h, all to some number, plus k, and I'm going to put a plus or minus here. That's where the reflection over the y-axis comes in. So stretching by a factor of 3 is going to be your a value. Translated right to is your h value. Everything else you don't write. I don't write this guy. I don't write that guy. And I don't write this one actually either. Actually, I lied. You do write the a. You don't use this one, you don't use this one, or you don't use that one. Okay? So when we write this, it would be g of x is equal to 3 parentheses x minus our h value. So our h value is 2. I'm going to plug that in. And now we just need to figure out what the power is. Well, this guy right here tells us the power. So the power of 5. Let's do it again. Reflected over the x-axis tells us that there's going to be a negative right next to the equal sign. So when I do this, g of x, the negative is going to be right there next to it. And then up 3 units is going to be your k value. So I don't have an h, I don't have an a, so I'm just going to write x to the power of 3 plus 3, because that's what we're moving up. Let's do it again. I have a compression of 1/2, which is what your a value is. Reflected over the x-axis, that means that I have a negative right next to the equal sign. If it was y would look like this. That would be y. And then left 1, so that's your h value, and left 1's always negative. So here we go, g of x is equal to a negative, because we're reflecting, 1/2 x minus whatever our h value is. Well, our h value is -1, so it changes it to a +1 to the power of 5. And again, go back and check, does that make sense? This means reflection, this means compression, this means left 1. You did it right. One more time. Compression is 1/3. And we're going down 2 units, so that's my k value, and that's -2. And I have no other pieces in my formula. Okay, so I don't have this value. I do have the a value. I'm not reflecting at all, and I'm not moving left or right. So the only pieces you have are what's left up there. So I have g of x is equal to 1/3 x to the power of 4 minus 2, because I'm going down. Always go back and check and see if you did it right. So when I go back and check, I am compressing and I am moving down 2. That's all I had on my problem there. Okay, transformations. You guys got really good at this. So this +2 means that we are moving left 2, and this -3 here means I'm moving down 3. So I'm going to go ahead and I'm going to put that on my graph right away. Left 2, down 1, 2, 3. That is going to become that middle point right here. Left 2, down 3. That's what that ordered pair is. -2, comma, -3. That's what that ordered pair is. So I need to pick 2 points above it. So -3 and -4. And then the 2 other points, so -1 and 0. Now, you can go ahead and plug those into your calculator. So I'm going to go to y equals, clear it out, and let's plug this in. Parentheses, x plus 2, close it up, to the power of 3. Press the right button to get out of there. -3. And we really just want the table, so press the blue button second, and then graph. And I like to put my cursor where that -2, 3 is. So here's -2, 3. I need those other 2 points. So I need -4, -11, and I need -2, and I need that 5. So let's go ahead and graph this guy. Here we go. -4, 1, 2, 3, 4, down 11 is like all the way down here. -3 down -4 is right there. And then -1 down 2. and then 0, 5, 1, 2, 3, 4, 5. From left to right, connect the points, and you are done. Okay, you could always press pause if this is going too fast. This next part, that negative means that we are reflecting over the x-axis, and that 1/3 means we are compressing by 1/3. So let's go ahead and talk about that. If you're not moving left, right, up, or down, you're always going to start at 0, 0. So that's telling me that I am going to start at 0, 0. And let's go ahead and get a graph on the paper here. Now you could just plug them into your calculator if you want. If you don't want to graph it, press y equals, clear it out. Let's type in that original function. -1 divided by 2 is 1/2. Parentheses x to the power of 3. To get your table, press second graph. I'm going to put my cursor on 0, 0 so I know I have to use the points above it and below it. So it looks like I have -1, 0.5. I have -2, 4. I also have 1, -0.5, and I have 2, -4. Let's go ahead and graph that. -1 down 1/2. Oh, sorry. -1 up 1/2. -2 up 1, 2, 3, 4. 1 down 1/2. 2 down 1, 2, 3, 4. Left to right, connect the dots. And we're done. Last part here. You guys got really good at this yesterday. Determine the degree, even or odd, leading coefficient, positive or negative, for each function. Then complete the end behavior statement. So remember, even is the same arrows and odd is opposite. So this guy has opposite arrows, so I know it's odd. This guy has the same arrows, so it's even. Now, leading coefficient depends on the last arrow. So these arrows right here are going to tell us what our leading coefficient is. So this guy is going to positive infinity, so it's positive. This guy is also going to positive infinity, so it's also positive. Limit statements. As x is getting smaller, here's x, it's going towards negative infinity. The graph itself is going to also negative infinity. Then we have this guy is going to positive x. Here it goes. It's going to positive. X is getting bigger, bigger, bigger. The graph is going up to positive infinity. Let's do the limit statements for number 11. As x is getting smaller, here it is, it's getting smaller. The graph is going up to positive, and then as x is getting bigger, the graph is also getting bigger. Same arrows, so it's a little bit easier on those ones. So that was a brief summary of everything that we've done so far. Again, you could have pressed pause if it was going too fast. At this point, go show the sub your notes that you've completed so that you can get the mirrored example. So the review you're going to pick up is exactly like the one we just did so that you can use it to help you out. And then you should be ready to go because we're only learning one more thing on Monday. Then we're reviewing and then we're testing. Okay, so this is pretty much what's going to be on the test. So please take it seriously. I hope you have a great weekend.